Hi, my name's Walter Bender, and I'm going to talk to you today about music blocks, which is a tool for exploring both music and mathematics and computation. It's something that we've been developing for quite some time at Sugar Labs, and very excited to have a chance to tell you about it today. So part of the inspiration for this project is there really is a very deep connection between mathematics and music, and it's been something that's been remarked upon by many different musicians over the years, and many of my colleagues at MIT who study mathematics or study computer science are also quite remarkable musicians. There's definitely something there, and although we know it instinctively, we don't really know much about it in terms of its actual substance, and that's really part of what music blocks is all about. In fact, one of the things that I'm most proud of is there's a colleague, a teacher who first used music blocks a few years back, and she said, I've been doing music all my life, and people have always told me there's a connection between mathematics and music, but I never understood what it meant until I used music blocks. So the inspiration for this project is actually from a paper from 1971 by Seymour Papert and Cynthia Solomon. And in that paper they describe, this is in the very early days of the Logo language, the first language dedicated to introducing children to computation. And they described a lot of different things: robotics, painting, different types of games. But a few of the ideas in the paper, a few of the things to explore, had to do with music. And these were actually ideas that were contributed by this gentleman, Marvin Minsky. Marvin is he passed away about a year ago now, but and his daughter Margaret actually is speaking at the conference. Marvin was the inventor of the field of artificial intelligence, but in addition to that, he contributed many of the ideas to Logo, thought deeply about computation and learning. And one of the things that he invented in the 1960s that's sitting on his lap is the first digital synthesizer. And when he invented the synthesizer, he and Ed Fredkin started a company to sell the synthesizer, and they distributed not just with a user manual, how to use the synthesizer, but also a book on music theory. So even in the 60s, Marvin was thinking about music as a pedagogy, not just music as something that you do. And he contributed some ideas around music to the 20 Things to Do with a Computer paper, and those are the things that we sort of expanded upon in music blocks. So there are two different approaches to using a synthesizer, and they're shown in this table. On the top is an example of the song Frère Jacques, and to play Frère Jacques, you can just send notes one after another to the synthesizer, and you play the song. But there's a second approach, and the one that Marvin espoused, which is to say that music actually is not just notes, but music structure. And Frère Jacques is actually a very structured piece, and you can see that Frère Jacques is composed of 4 parts, and each part's repeated twice to create the music. So Marvin exposed to the children not just the ability to make music, but also the ability to explore musical structure. And that's what we really have pushed very hard with music blocks. And part of this is also inspired by some observations by Seymour Papert in about 10 years after that original paper. He talked about microworlds as a place to explore an idea that's sufficiently rich that you can really have a significant understanding and a significant experience. And so we've tried to make a musical microworld, one that's sufficiently rich both in terms of its music and also in terms of computation. And that's what music blocks is. So the basic idea is that we have this core object we've introduced to the language, the note. And the note has both an ability to control rhythm and also an ability to control tone. So with it, we can essentially make these little events that happen over time, and they're things that are contained in the event, these temporal quanta. So it might be a G an octave 4 for a quarter note, or it might be some other note, or it might be some notes and some graphics. You can put lots of different things in, and I'll show you a number of examples towards the end of my talk. But in addition to having a note, we also have musical structure. And music involves repetition, it involves transposition, inversion, many different things. There are many different ways in which we take the basic note, combine it into melodies and phrases, and then we use those phrases and transform them in different ways. So Music Blocks lets you do that while exploring both music and computation. So the basic here is Frere Jacques done in Music Blocks, and you start off again with just a collection of notes, and then you put those notes inside of what we'll call an action or a phrase, and then you can repeat those actions over and over again, mix them with other actions to get the song. We also then can do transformations of those phrases. So in this case, what we're doing is we're transposing the sound. We're popping it up or dropping it down by an octave. So we have a tenor voice, we've got a bass, a soprano, a baritone. So we can have different ways of taking the same phrase, the same musical phrase, and transforming it so it sounds quite different. And this is very typical of how music is put together. So in Music Blocks, each start block in the CR gives you a different voice, and we can transform those different voices in different ways. We can also be much more explicit about the mathematics. This is an example of Fibonacci, the Fibonacci sequence, which is essentially 1, 1, 2, 3, 5, 8, 13. I think you're all probably familiar with it. You take the previous two numbers in the sequence, add them together to get the next number in the sequence. And it's very common in nature. You can see the shape of the nautilus that's being drawn here. And what we do in this case is we combine the mathematics with music, and we transform the music, the note, based on the current Fibonacci number. We also can introduce concepts like recursion. This is an example of where we draw a tree and we use recursion, and we combine. Actually, another speaker at the conference was confused about recursion, and I had a long talk with her about it, and we introduced the idea of making the music recurse throughout the drawing as well, and that's really what drove home the idea. And then finally, with all these tools that we develop at Sugar Labs, we don't think of them as destinations. We don't think of Music Blocks as a place where you're going to stop, but rather it's a point along the way. It's a waypoint along the way to even richer interaction with music and deeper reflections about music. So one of the things we let you do with Music Blocks is not just create music within Music Blocks, but also go beyond Music Blocks to the next thing. So one of the things you can do is you can export your project in Music Blocks and turn it into sheet music, for example. So you can see the relationship between what you've done in the programming language and what traditional musicians use as their tool of communication. So a number of different demonstrations. So, back. Music Blocks is being used all around the world. It's also being developed by engineers all around the world. I'm excited to say we're about to start a major intervention in the Japanese public schools. Every school in Japan is going to start using Music Blocks, and just a tip of the hat to my colleagues in Japan who've been helping so much. The other point I want to make about Music Blocks and all the work we've done at Sugar Labs is it's software libre. It's not software gratis. It's all about letting the children who use the software, use the tools, not just have access to the tools themselves, but also understand how the tools work. And it's really important. There's a distinction between letting people use a tool, letting people see how the tool works, letting people have the license to change the tool, and then finally giving people the scaffolding, the support they need to actually engage in that process. And Sugar Labs tries to cover that entire spectrum. We provide rich tools. We also provide the source to every tool that we deliver. But we also provide a license, the GPL license, that says you can not only see this software and see how it works, but you also are allowed to, encouraged to take ownership and change the work. And then finally, we build into Sugar many, many different tools to make it easier for the children to get engaged and be participants in the actual development of the tools they use. And just by way of example, 63 people have contributed to Sugar Labs. 63 people have contributed to Music Blocks to date, and of those 63, probably about 45 are children, teenagers. And so it's been a really rich experience. I learn a lot from the kids, and hopefully they're learning a lot by participating. You can get Music Blocks here. You can get the source code as well from our GitHub repository. I encourage you to play with it, use it, explore it, enjoy it, and make contributions to it. And then finally, I want to bring up one other concept that Marvin espoused. Marvin was often would say you'd never understand something unless you understand it in more than one way. And in exploring music within the context of Music Blocks, you get many, many different perspectives on music and many, many different perspectives on mathematics. And part of what happens in exploring something like this and living in this micro world, you build a tower, you build a structure, a cognitive structure, and that cognitive structure then can be applied not just to music and not just to programming, but to many, many other domains. And with that, thank you very much. You can send me questions to my email, walter@sugarlabs.org, and pleasure. Thank you. Finally, a tip of the hat to my colleagues. Cynthia Solomon and Devin Ulibarri have been fundamental in helping me develop Music Blocks. The community at Sugar Labs has been a really rich place to work for the last 12 years. Music Blocks contributors, especially the kids, the Software Freedom Conservancy, which is our foundation, and the Free Software Foundation that oversees all of free software all around the world. And then finally Google, who's sponsored many interns